On this episode of 5 Minutes of Cloud, we're going to talk service mesh and specifically Istio. If you've been working at all in the microservices space over the past couple of years, the concept of a service mesh is probably not new to you. For the rest of us, it's sort of born out of some of the needs that the microservices space has really driven, specifically some needs around visibility, even traffic routing, authentication and security, and metrics collection as well. The problem stems from the fact that within the cloud space, and specifically the microservices space, as we move our services into containers, which is a very common model, we lose some of the visibility that we used to have in, or some of the instrumentation that we were easily able to do in a classic monolithic application. For example, in a monolithic application, the internal services within the application would communicate through internal messaging, and those message communications paradigms would often be managed through interaction within the application itself. You could basically monitor memory spaces for messages being passed between different resources. When we went to microservices, suddenly that was no longer easily accomplished. And when we went to containers, we suddenly lost the ability to just add some additional services into our base virtual machine to gather that information. Well, this is kind of where the service mesh concept comes into play. Let's put something in between all of our microservices and then capture all the traffic that goes between them. Well, this creates a bit of a problem, especially in a distributed system where I suddenly have to figure out how do I manage all of those interceding little components that are actually monitoring and metering my services. Well, along comes Kubernetes, and suddenly the game changes pretty dramatically. It's not that we couldn't implement those service functions, but now we have a way of just injecting that functionality directly next to the individual service containers themselves. This is done through a technique called service injection, or effectively adding another container into our environment. And then on top of that, since we're usually looking at network traffic, again, we're talking about microservices as being the principal model for this communication, we can actually start tying the services in at the very edge of the network. So by doing that, or rather within the pod itself, we're actually redirecting the local traffic. Now, by doing that, we fix some of the problems that microservices have, specifically the ability to monitor communications between resources. So that's one of the things that Google actually brought into the Istio space, was the ability to sort of capture this data, effectively extending the concept of the container engine, the C-advisor engine for the container runtime that people are using, into the application space, basically being able to look at the application data stream as well, and then centralizing that metrics data and potentially the monitoring of communications. Once I've done that, once I've injected myself at that level that I'm looking at packets flowing back and forth, I can do some really interesting things. Like I can add authentication. And so this is one of the things that IBM contributed to the mix. On top of routing was the ability to sort of secure the connections between these different services. Routing is another thing. I have control over where any frame gets sent, rather than just saying, well, I'm going to always forward to a load balancer that's going to distribute to n number of resources. That load balancer becomes part of my communication, and now I can actually decide which target am I actually going to send these frames to. Very powerful. And since I have this level of control, I can even do some interesting things like inject fault. So when I start distributing my application to these microservices, it gets harder to figure out how my application is going to behave if something breaks. How do I actually force failures in any one particular microservice to check how my application remains resilient in face of that kind of a failure? Well, I can now start injecting that as a part of either my QA or development process, all the way up to even including that injection at the production level. I can continue to create faults to make sure that my system continues to behave properly, and if not, I can actually alert against that. So this is some of the interaction that the microservices mesh, service mesh space actually provides, and Istio helps provide this through an injectable proxy. So basically I'm going to take a proxy engine. In this case, they're using, or the Istio space is using the Envoy proxy, which was initially developed by Lyft, is now an open source project, a part of the CNCF. Actually, Istio is also part of the CNCF, and for those of you that haven't heard of that, that's the Cloud Native Compute Foundation, which is a sub foundation within the Linux Foundation space. So this service functionality is really what Istio is providing. Istio provides this Envoy proxy capability that gets injected with each container in the Kubernetes space, or gets inserted into the forwarding path if you want to use a non-Kubernetes model, either with containers like Docker or even virtual machines. You could actually add this proxy as a process within a virtual machine and inject traffic through that way. So we can use microservices, we can use mega services, monolithic services as well, and we can use this service mesh to tie them all together. But with Istio specifically, we get authentication. So because all traffic is going through these Envoy proxies, I can actually authenticate end-to-end communication. I can monitor and meter traffic, understand what's going on, what latencies look like, what kind of throughput I'm getting on a path-by-path basis. I can send that to a central tracing service, open tracing, like the Jaeger project is one of the fairly common ones that gets used there. I can also start looking at routing. Like I said, I can redirect traffic, and I can do that based on, within the Kubernetes space, for example, I can just use labels to actually define where my endpoints are and what services are supposed to go where. So that's incredibly powerful. But I also have central control, and this is sort of the last thing that Istio brings is central certificate control. That's important for the TLS authentication. Central metrics gathering with a tool called Mixer that actually gathers all the metrics data together, and then central configuration control. And this is actually why Envoy was picked as a proxy, because now I have a central controller that can distribute the configuration to all of the distributed proxies that are out there within that mesh. And Envoy does this in a very efficient fashion because it doesn't actually require a restart on reconfiguration. It can do a hot reconfiguration, so a pretty powerful tool. So service mesh is an important component of the microservices space, and it really changes how microservices are stitched together, how they're metered, monitored, and really even looking at improving the performance and the resiliency of those services by injecting fault, all from a centralized control plane with security. So lots of things all in that one big bundle, but that's really the Istio capabilities, and it's part of that greater service mesh space within the cloud native engine that is really sort of taking over how applications are built these days. This has been Robert Starmer, bringing you another episode of 5 Minutes of Cloud. Don't forget to look us up online. We have a number of classes and training that sort of support this concept, these ideas. And of course, we have our blog and newsletter, and we love to keep you informed either through this channel or many of our others on what we're doing and helping people to really get the most efficient utilization out of their cloud resources. So let's dive a little deeper into the concepts behind Istio. One of the biggest values is the ability to start managing and monitoring a microservice-based environment. Now, one of the first things that happened in the microservices space was that the developers suddenly started realizing that it was very hard to find a single way to provide some of the communications requirements, especially when we started talking about securing communications between resources. How do you start sharing those certificates and making the communications viable? Often developers didn't want to all use the same language, so even if you found a library that looked useful within one language space, so let's say in the Java space, maybe there were some really good remote procedure call language libraries that would provide you with security, traffic routing and metrics gathering sorts of capabilities. Often that only worked within the Java environment. It wouldn't work with a Ruby application or a Python application or something written in Go or compiled in C. All these languages all have their own value, and especially when we're looking at breaking things down into services, especially services that have a RESTful interface, or maybe now more commonly a gRPC interface, we found that there were a number of points of value that could be derived from understanding the interaction between these resources, and especially because we started using HTTP or HTTPS more likely as our transport, it was actually possible to start injecting basically an interface in the middle of these systems. And this is what led to this concept of a service mesh. And now, again, this isn't really new, but what's new about it is the concept of decentralizing that mesh and taking it out of the library space and placing it in a sidecar application. Now, sidecar applications are a term that's really specific to the Kubernetes and containerized cloud development workflow. But it is a technology that's really sort of changing how we think about building those kinds of services. And of course, as soon as we start thinking about building services like this, we start thinking about how we have to tie in still some potentially monolithic or legacy components, and wanting to be able to use these same tools to allow those communications to become more efficient. So the first thing that we find in the Kubernetes and Istio space, the service mesh space, driven by Kubernetes, and really I think now becoming the space of Istio as the answer here, is this ability to inject a proxy component next to the services and then route all of our traffic through that proxy. As soon as I've done that, now the proxy takes on the task of redirecting traffic if the microservice or monolithic service that the proxy is sitting in front of. That's one piece of the puzzle. Another piece is actually gathering metrics and potentially injecting fault at that point. Another very powerful component of the system. Authentication, mutual authentication, especially being able to sort of certify that not only does the service know who it is, in other words, it can we do the classic like TLS lookup that you use from your web browser to any secured website, but we can do the inverse as well. So basically both sides of the connection can guarantee that the remote end is somebody that they know about, or at least somebody that they feel secure talking to. In order to get all of these pieces to work together, and of course there's also one more piece, which is this concept of routing traffic. Hey, I want to send from one service to another, but maybe I have two versions of a service, especially common in environments like blue-green deployments or even canary deployments. These are environments where I'm going to launch a specific subcomponent of my system, for example, a new resource, but I don't want to release that to everybody because I want to see, is it going to scale? Is the latency still appropriate? Is it failing to be able to communicate properly to the backend? I want to do this on a small scale and then maybe scale it out. Or I want to actually roll out enough capacity so that I can almost do a flip-flop. Hey, I'll take my one system and immediately redirect all traffic to the new system, but I have to have the appropriate scale to do that. One of the reasons that this is very popular in the Kubernetes environment is that it's very easy, often very simplistic, to say, well, I could spin up two containers side by side, the old version, the blue version, and the new version, the green version, on the same machine at the same level of scale, and because the new version isn't necessarily consuming any resources until I start directing traffic to it, I even have capacity potentially to drain from one system and start building up traffic on another system within the same compute footprint. So I actually have some real interesting flexibility there. But this class of functionality is one of the key things that Istio brings to the table, is the ability to support all of these different use cases. So I have routing capability, redirecting traffic, so this blue, green, or canary model. I have the ability to capture metrics and understand what's going on between resources. I can inject fault into the environment, and that's actually important from the perspective of, in the sort of development QA staging environment, understanding how our system behaves. But within the production environment, it may also be useful to ensure that there isn't something in the production space that breaks just because we inject a fault somewhere. So we want to be able to continually test our environments by using these different services. The thing that a tool like Istio brings to the table is the control plane for this class of function, because now I have a distributed environment, like containers on multiple nodes, and I have a distributed set of resources that those containers plug into. So it's a very powerful tool to support all of this. Now, if we start thinking about how the pieces need to fit together, we can talk about the resources that make up an Istio environment. And here we see a number of different components. The most important and perhaps the critical component in all of this is Envoy. Envoy is an HTTP or TCP capable proxy, and in being so, it's a proxy service that has one other key feature, and that is that it can do hot restart. What this means is that I can talk to Envoy via an API and pass in a new configuration. For example, I want you to route traffic to a specific labeled resource, maybe a different service name within the Kubernetes forwarding space, or even just a different target IP address and port. And I can pass that configuration information into Envoy via an API and tell Envoy Envoy, as of now, as soon as you see this information, go ahead and just any new packets that show up, forward them to the new flow. I can also deal with flow draining and all the other sorts of load balancing type functions that I might want within that service. So Envoy is great as that edge proxy. I also have the ability through Envoy to inject faults. So again, being able to use Envoy as the engine for my service mesh is very powerful, because I can use it to support those use cases of making sure that my system remains resilient and functional within the overall environment. So again, a very powerful component. I need to be able to gather metrics. It turns out that Envoy is great at least being able to capture the metrics data that is needed and redirecting that to the right target domain. Lastly, I also want to be able to deal with security. So I want to be able to authenticate resources. The nice thing here, again, I have this hot restart capability. So if I want to roll keys up into the system and send a new set of keys or a new set of certificates to support the authentication process, maybe I feel that there might have been a failure, or just as a part of my normal security process, I want to keep my certificates constantly being updated. I can do that because I have the ability to just inject the new certificate into the system. And so the next time an authentication request comes in, I'm using the new certificate rather than the old one, and everything continues to operate properly. These are really powerful tools, and Envoy really just makes it easy to support all the features of the environment. Now, Envoy can't work in a vacuum, unfortunately. Something still has to provide configuration to it. It is absolutely possible to write an Envoy configuration file and include that as a part of a container launch process, and there you go, you have a static proxy. Where it gets more interesting, of course, is when you have a service, both a target service to receive traffic, so the metrics data, for example, and a service to actually manage the distributed configuration of all these different resources. One of the interesting things about the Kubernetes space is that, of course, it is a centrally managed resource. The Kubernetes control plane knows what's going on within its Kubernetes environment, which means that it's easy to effectively take that, build out a map of all the resources that exist, understand where they exist, on what ports they live on what IP addresses they live on, what cluster IP or behind what load balancing IP, if appropriate, they live on, and actually connecting all those resources together. So it's very simple because of that central knowledge for another central component, in this case the component called Pilot within the Istio space, to actually manage configuration. And so you can post new configuration to Pilot anytime you want to make a change in your system, and actually have that change automatically propagate out to all the remote resources to actually enable that class of service. So it's really a very powerful tool to have that central control with Pilot. The next thing that we want to do, of course, is collect these metrics and understand how the system is behaving if I pass things like a 503 not available error, or a 404 can't find it error, or a 304 permanently redirected error. All of these sorts of things can be injected into the system. Obviously, you don't want to do things permanently in an environment that is as dynamic as microservices space, but it would be interesting to see how your system behaves if you do that. These are the sorts of things that you can also do. And again, it's that hot configuration capability, hot restart configuration capability of the Istio or the Envoy load balancer that makes this possible. But we're going to direct that data back to Mixer, which is the central service that actually collects the metrics data. And again, Pilot is actually going to drive the configuration out to those edge resources. There are two other services within the Istio space that are probably worth talking about. One is the certificate authority. This has been recently renamed to Citadel as a project, just to manage the number of certificates that have to get created and managed. Now, these are all self-signed effectively. They're assigned from that local centralized resource. I believe that there are even ways of using, if you have your own certificate authority and you actually want to include the chain of control all the way up through that, it is possible to do that by delegating some capacity or some authority back into your Citadel CA. But the Citadel CA is what provides that central resource, and provides that central authentication service, and also distributes out the keys and the certificates for supporting that mutual authentication process. The other service that's important in the Istio space is an ingress service. Because everything is mutually authenticated, it's actually important that all of the service endpoints be able to talk to each other. And if you need to get into that environment, you need something that can basically translate from external certificates into the forwarding certificates that are needed within the mesh itself. And that's really where the Ingress Controller comes into play. This is another version of Envoy. It's just configured slightly differently to act like a public service on the public side, and then drive that traffic into the service mesh, and of course load balance as needed against the front end service that is being presented through that resource. So Ingress is another component. Ingress works in conjunction with things like the load balancing service within Kubernetes, and in a sense you actually end up with sort of two load balancers in a row, but this allows us to get all this other benefit from the service mesh, so it's actually kind of an important component. Now, one of the other interesting things is that the service mesh, because it is looking for mutually authenticatable resources, assumes that it can't mutually authenticate with something outside of its local mesh. And so you actually have to specifically tell something like the Ingress service to allow traffic to be redirected out of the local mesh in order to actually have things talk to, for example, remote resources. Now, in many services, especially microservices environments, this is not as common as it may originally seem, but it becomes really interesting when you start thinking about taking a Kubernetes embedded service mesh and its Ingress controller and connecting that resource to that service and that service mesh to a resource that is effectively outside of the Kubernetes instantiated mesh. Now, in reality, the Istio plane works anywhere in multiple different modes, so long as you have an Envoy load balancer at the edge of the network. And this multi-dimensional, multi-service capabilities, I think one of the areas where Envoy really shines. So when we talk about Envoy as or rather Istio as a tool for handling multi-environment sorts of things, we can start thinking about Istio as a hybrid cloud enabler. I actually think there's the potential for Istio to suddenly become a VPN killer in a sense, in that I no longer have to necessarily have VPCs, or if I do, I don't have to stand up static VPN services into those environments. So long as I have a way to get into that virtual private cloud environment in whichever cloud I happen to be working in, I can potentially expand the Istio cluster outside of that. Now, the one trick here is that certificate authority, Citadel, in the Kubernetes deployment, for example. How do I enable access to that resource so that my certificates for my static resources, my VM-based resources, or my other cloud resources can actually get access to the same service? This is something that's still in flux and it's being worked on. Right now, you effectively have to provide a path, which breaks this ability to sort of break the VPN, but you have to provide a path to effectively a single pilot, because you still need one controller that can sort of understand the entire system and control, but also one access to a single Citadel to get certificates and push those certificates out to the remote resources. So long as it's possible to sort of expose the central control for your one Istio mesh, it certainly is possible to build hybrid environments, public-private, public-public, etc., sorts of cloud environments that can actually tie all these different resources together. And I think this is the area that as Istio continues to mature, we will see more of this class of resource, tying, I think, classic old school deployed systems models, or even modern enterprise applications that are not yet containerized, that still live in a VM world, maybe don't even have the web scale systems model, but are still important components for an enterprise's application environment. I think we're going to see more and more of these environments become Istio enabled, basically allowed to join that one central mesh and tie into the new microservices systems environments. So in summary, Istio is a new service mesh technology. It's been around for about a year, initially developed by Google, IBM, and Lyft providing Envoy, IBM providing principally the routing capabilities and central management model. Google also provided some central management service, but started looking at security and at the metrics collection aspects of mesh and what a service mesh was needed for in terms of microservices deployments. Istio does that by tying these pieces together, providing a central control plane with pilot, mixer, Citadel and the Ingress Controller that's needed to sort of stitch these resources together and provide a way to get in and out of that mesh. And of course, we can work within a Kubernetes environment, a standard container-based, for example, a Docker container environment, or even directly on virtual machines or physical resources, so long as I can add in an Envoy proxy, and so long as that Envoy proxy can still get access to and talk to Pilot for its configuration, the mixer for its metrics, and Citadel to get certificates so that we can do the mutual authentication component. I really think that Istio is going to change the game for a lot of application deployments. It's going to make it easier in certain environments to deploy hybrid-like use cases, and I really am a strong proponent and strong believer in what the service mesh technology brings, not only to microservices, but to applications in general.